Hello, everybody. I am happy to talk today to Abhimanu Kumar, an expert in machine learning and AI. Abhimanu has formerly held senior data scientist positions at companies like Apple, Microsoft, and Groupon before starting his own business. He is the co-founder and CEO of Causal Funnel, a company that helps small and medium businesses compete with the Amazons of the world by providing them with all the AI and data science tools they need to increase traffic and conversions. Abhimanu has extensive experience in machine learning and artificial intelligence and has authored and co-authored multiple well-cited publications in many subfields of ML and AI. Today, we are going to learn a great deal about the topics of machine learning and AI, and I'm sure everyone will benefit from Abhimanu's valuable experience in the domain. Abhi, welcome to the IJK Podcast.
Awesome. Yeah. Thank you, Matt, for thanks a lot for that introduction. It's been a pleasure, talking to you, and I'm very impressed by your credentials as well. It's amazing what you have accomplished.
Thank you very much, Abhi. Thanks for joining us today as well. I would like to start with some generalities. Let's say, what are some simple, clear definitions of artificial intelligence and machine learning that will be easy for everyone to understand?
Absolutely. So AI has been such a generic term. We have been talking about it for almost 1930s and even before that. And the way I see it is basically machines doing intelligent work, right? Just to be very very simplistic about it. Now, if you talk about intelligence, that itself is very debatable. What is intelligence, right? We know artificial intelligence, right? Okay, we can say, machines, when they become intelligent, artificial intelligence in general, just being simplistic here. But then what is intelligence? What do you define as intelligence? And there are a lot of debates around it, can you look at the world, analyze all the knowledge in that world and the data, and then make inferences? That's one definition. Some people say the intelligence is kind of like an instinct, right? Which is there. And there are different kinds of intelligence. For example, there's a book called Language Instinct. I don't know if you've heard about it or not. It's a popular a science book by Steve Pinker. And in that, he argues that there's an instinct for language in humans, which is not there in other kind of, other living objects in the. Yeah. So then it becomes really kind of abstract discussion at some point. But the way to see artificial intelligence is basically machines doing intelligent work.
Okay. And if we want to define as well quickly machine learning itself. So I know that it's not the same thing. AI is not the same thing as machine learning. AI utilizes machine learning, right?
Absolutely, yes.
Yeah.
Yes.
So can we
yes.
define it a little bit? Machine learning?
Yes, absolutely. Yeah. So most of my grad school work has been in machine learning and a little bit of deep learning. I wouldn't say a little bit, but fair deep learning. So the way we define machine learning is machines learning from patterns. Now, the patterns could be coming from any kind of data. It could be text data. It could be language data. It could be video data. It could be time series data, in stock market and all that, right? So that's where machine learning is. Now, you didn't ask this question, but I'll just dive in anyways. The part where deep learning comes in, right? That's where it becomes much more interesting, because now we're talking about structure and the framework in which we learn pattern as well, right? So, and generally it's artificial neural networks. You have structured matrices, basically learning the patterns. So that's where the whole subdivision of deep learning and so on and so forth.
Okay. Great.
Yeah.
Can you give some fun and relatable examples of how AI and machine learning are already impacting our daily lives today?
Absolutely. So, for example, the obvious ones are the recommendations on Amazon and YouTube, and a bunch of all those recommendation engines on Spotify, on YouTube. You see, it's all machine learning, deep learning. The more interesting ones are where you bring in causality, right? So that's what I find most interesting in like the pattern learning, right? Pattern recognition or AI, is that can you define causality in that learning? And so a lot of like when you start working on drug discovery and what effects drugs have on people, that's where you are talking about like causality and those sort of things. And that's when things are really, much more complex and much more interesting, and like solve our much more kind of base needs, like, our life, our health, our security, and so on and so forth.
So when you talk about causality, in the context, let's take it in the context of pharmaceuticals first. So what you're trying to say is sometimes we find that a certain medication works and it's healing the patient. However, we don't know exactly the mechanism that actually is causing this healing. That's what you're saying. And we have the same thing in AI as well.
Yeah. So that's why. So that's been a discussion, like, philosophical discussion, machine learning, AI discussion for a long while actually, causation and correlation, right? And you will see that machine learning patterns that fail, they mostly fail to make the distinction between the two. For example, there is that famous example wherein like there was this big firm in Valley who were predicting the housing prices, and like, the whole thing didn't work out, and they were training really complex models. And, most likely the reason was they were basically, there was this confusion between correlation and causation. Whenever you make that confusion, it is coming back to bite you back, and your predictions, whatever you're doing. Yeah.
I see.
Yeah.
Great. I mean, all these questions are very interesting, and I think very current and relevant today in the field of machine learning and AI. Question to you. To be able to judge or to be able to say that a certain AI model is good, or let's say is competent or effective, do we need to go to the root cause and understand how it works, or it's not necessary?
That's a great question. It's like, okay, there is gravity, right? But like, these are like, unless it's falsified in some environment, it holds true, right? So there are ways to know if your machine learning algorithm is actually learning correlations or it's actually finding the inherent patterns. And like, we do like things like, we separate the data into 2 or 3 pieces. One is like just to train the algorithm, and then another part of the data is just to test it. And then we test it in the wild, like really crazy, all kinds of examples and so on and so forth. So basically you make the model really robust, it doesn't overfit and all that good stuff, right? So there are those cases, right? And if you can get the exact universal representation of the data of the problem that you're trying to solve, then with the confidence you can say yes. But if you do not, it's a very data way of looking at things. But that's how empirical machine learning people solve this problem that you're talking about.
Okay, and I hear sometimes the term explainable, like this is an explainable AI model. Does this tie in with the causality or not necessarily? Sorry.
Yes and no. Causality also has to answer counterfactuals. The explainable models do not always answer counterfactuals. So so that's why I say yes and no. It goes to that place, but I'm not sure if it's fully capturing that idea of causality.
Understood. Can we now introduce a bit the concept of data in general and its importance in AI and machine learning without getting too technical. So we live surrounded by data, but how important is data for our machine learning and AI technology? And can we kind of define it in a way that everybody can understand as well?
Yeah. So the way you would look at data, I mean, it's a very cliched saying, but basically, it's like, you are trying to find the pattern in predicting an outcome or an answer. And the way you learn that is using these pattern recognition algorithms. And what do you learn pattern on? You learn pattern on all the instances of that particular event you have seen. So that event, those instances become data. Now, there is another way of, predicting an outcome, which is rules-based, right? And it used to happen as well. And there are, of course, and when you empirically design systems, there are certain, a priori beliefs and rules that you can put in or feed into the system. But data is basically instances of those events that you have observed, right? And then you're finding a pattern in those instances, right? So it's a very statistical way, you are counting eggs or counting chickens, and you say, okay, there are these, eggs of red type, these eggs of, yellow type, these eggs of white type, and what is if I choose an egg blindfolded, what is the probability that? So it's like counting, drawing patterns on the instances of those events. And then basically that's what data is.
Okay, so it's a collection of instances and modalities maybe and attributes of whatever we are analyzing or whatever we are.
Yeah, exactly. In a certain sense, right? Modality is slightly different in the sense that we are speaking. That's one mode of communication. The other is the video, right? Our expressions and all that, right? So that's another mode. Now, if you want to predict a wholesome picture of the next set of events that's going to happen, then you would combine everything. So that's kind of multimodal, right? So that's
one step.
One way folks define modality.
All right. Okay. Can we explain now how machine actually learn from data? I know you touched a bit upon that by saying they learn from patterns, but can we provide a bit more detail? How do machines actually learn from data? Is there a process that data scientists use to kind of make the machine memorize or understand a certain pattern?
Absolutely. So so when you do statistical learning, basically learning from counting, like I said, there's rule-based, and then there is data-based, and there are other you can also argue about other things, but let's stick to counting-based learning or statistical learning, which is machine learning, the modern machine learning that we are doing. So basically, it's all conditional probabilities, right? So suppose, let's take a simple example. If I know that on my left-hand side in the data set, there are only brown eggs, and on the right-hand side, there are only white eggs. Given I have lifted my left hand to pick an egg, what is the likelihood that I'll get a white egg? 0, right? So basically, you are learning these patterns from the data, and then you are basically trying to predict in an unseen data that you've not seen before in your training sample, what is the outcome going to be.
And it's all based on statistics, probabilities and statistics play a big role in machine learning and...
modern machine learning, yeah, absolutely. So all the newer techniques that you see, like deep learning, artificial neural networks, machine learning, all the newer, basically AI revolution happened once people started using data to learn the patterns. Earlier, there were rule-based systems as well, But once people started using data to learn patterns, like whether in linguistics, computational linguistics, or in audio or video, the algorithms became really well in predicting the next set of things.
Is a rule-based system, employing the classic if then else, is it still considered AI, or that's a very basic form of AI?
Great question. Decision trees to a certain extent are like if then, you get at the top of the tree and then you say, okay, if it is, like I said, left or right, if it is left, I'll do this. There's a lot of statistics there as well, but you can see this as kind of a more statistical rule-based system, right? So absolute rule-based systems, they come in as priori beliefs, if you're taking, so let me talk to you about Bayesian statistics and frequentist statistics, right? So frequentist is basically you are doing the coin toss, you are basically, you are just looking at the data and then you're kind of saying that, okay, what is the likelihood that you will get a head or a tail? But in Bayesian statistics, you can basically put a rule or a prior belief that this coin is biased, right? So it's not always going to give you 0.5. It's not always give you equal opportunities of head and tail, but there's a prior, it's loaded towards head. So even if your coin toss for 10 or 20 or 30 instances is going to come as equally head and tail, you would still bias that with that initial belief or rule. So you can think of that as a kind of introducing a kind of a rule in the system. And earlier crude-based rules, those used to happen, but I don't think anybody is using those systems. It's mostly, counting-based statistical approaches, deep learning, machine learning, and AI, yeah.
Okay, interesting. And those deep learning, machine learning systems, are they all trained manually by engineers, or they can also learn by themselves?
That's a great question. So at this time, they are mostly manually trained. Autonomous learning, there is this new idea called self-supervised learning. There is a lot of work going on there. I have few papers there, but I won't consider myself an expert. There are much more scholarly people that are working there. I would say it's not there yet. And even if it's gonna be there, I would be doubtful how much of a self-supervised system or fully learning, auto-learning system it would be. There you can learn within your universe, your data universe. Yes, you can learn that, but if there is an instance that is outside of your data universe, it's hard because you are basically relying on the data to learn the patterns. So you see where I'm going with this.
Most current systems are supervised.
Supervised and unsupervised is slightly different.
Okay.
Supervised meaning you are given the outcome, right? So for example, given this egg is brown, you are and this egg is white, you are given these labels. When those labels are not given, it's called unsupervised. What I'm talking about is more like self-learning systems. Those ones, and in that context, the self-supervision also comes. But those are not yet at a point where, we can say, okay, yeah, they are auto-learning, they would basically be really good given infinite amount of time. Yeah.
Got it.
Yeah. So the whole idea of systems that will learn from the data as you give them more data, right? So basically it's there, right? You give them more data, they will learn from the data. But what people are working now on is basically can they go beyond that, right? And that's where that's where I think the next frontier would be, like some form of, artificial general intelligence, wherein even if you do not have like a lot of instances of that data, or you don't have that data, you can still make the prediction by like all the kind of complementary or supplementary or like near domain data. There is a lot to be done there. Like I said, there's no single definition of intelligence, right? There are like, mammals in the water that have, lot more, they can do a lot more than humans when they go to the water, right? So, so definition of intelligence, first we'll have to start from there, right? And then, we'll have to design a system that is AGI, right?
AGI, artificial
general intelligence.
Can we define a bit more AGI? Is this first feasible? So first, let's define AGI, and then second, is this actually something that we can get to at one point?
Yeah, so defining AGI is again like walking on eggshells. Like I said, there is no single definition of intelligence, right? You can be emotionally intelligent. You can be, really high, with really good with numbers. You can really good with
musically intelligent.
Exactly. There you go.
Yeah.
There you
like
go.
Mozart.
Right? Yeah. So what, when a person says AGI, at least in our context, what they generally mean is, can we create a robot that is really indistinguishable from humans, right? Like a way a human performs, a way a human thinks. Can they be part of the society and you can still not distinguish them? It's a very long shot, in my opinion. It's
we are bordering the domain of science fiction now, but okay. So you think it's not realistic right now, but maybe in the very long term, probably. Who knows?
Yeah, I mean, like before that happens, humans will start augmenting things to them, right? Like start adding chips to their hands, their hair, to their eyes, and you would like be like much more intelligent than what your ancestors were like just 2 generations back or 1 generations back, right? So that augmented intelligence is gonna happen much more sooner, way sooner than AGI. Sorry, go ahead. Yeah.
Like Elon Musk's Neuralink, for example, is this one area?
One example of augmented. Yeah, you can augment your capacities by adding like machine parts, right, and like get assistance from there. Yeah.
And how far are we in the progress? Did we progress in that area, or we're just like starting to think about these things, or no? There are some applications already, and it's proven to work to a certain extent.
Yeah. So when I was in my grad school, we used to analyze these voxels data, basically the MRI scan of data, and then predicting the action, right? Or like some other kind of some other prediction that you would do, right? So basically, you can analyze that data and you can kind of assist, there, right? But it's still an active research area. It's
we're still early stages.
It's early stages. Yes. Yeah.
Okay. Cool. All right. What are some exciting possibilities for how AI might actually be used in the future to improve our lives? So we know, for example, there are now self-driving cars that are being built. There is also this concept of personalized healthcare. But apart of these 2 areas, are there like exciting sectors that you think will be transformed with AI in the near future?
Yeah. So one thing I really believe, like before like even the whole self-driving thing, cars take off, is like self-driving like ships, right? Because there are not much rules when you're on the sea, right? There are no lanes, for most of the time, you can accelerate, decelerate, depending upon how choppy the waters are, right? So I think that self-driving ships would definitely be there before I feel self-driving cars are there. So that's definitely gonna happen. I believe. I think there are already companies working on that. The other thing would be like a lot of like augmented, robots assisting humans, right? All that thing like household chores, like, those are gonna happen.
Robot helper or
Robot
robot
helpers,
cleaner.
yeah, exactly. We already have Roomba, but it's not really intelligent. There would be like intelligent Roombas, like who can like just climb the walls and like wipe out all the spider webs that you have, if you have any, things like those, and like anticipate already the next action. If you have a kid and it's eating ice cream and it drops it, then like the Roomba would automatically be on like a standby position that the moment it's dropped, it's gonna clean it up. So those kind of things are gonna happen. But yeah.
Cool. The future sounds pretty exciting.
Yeah, it
Now
sounds
I'd like
exciting.
to. Yeah, definitely. Abi, I'd like to talk a bit more now about online marketing and e-commerce. How is AI currently changing that sector? And then later, I'm gonna ask a bit about your startup.
Yeah, absolutely. So the way it's changing is that so earlier what happened was the big companies, right? They can like basically create these really expensive algorithms that needs a lot of like PhD level graduate people and scientists and like a ton of data, right? And using that, they can predict like what's gonna be the behavior of the person, like based on these clicks and these actions, right? But what's happening now is that you can take that and you can smush that algorithm and you can personalize it for specific like stores, right? Like smaller and medium sized businesses, right? So that's one that's we are working on, basically helping small and medium-sized businesses do better A/B test, improve their algorithms, their prediction capability based on that, even if like they don't have ton of data or like they don't have the capability because they can't hire like really expensive machine learning engineers or data scientists. So that's one. The other is like these AI bots that are gonna augment the customer service industry, right? So, for example, you're a United States company, you have an online store, and then you have a buyer coming from, say, Turkey or say France, right? And it's nighttime here, right? Or say UK, it's nighttime here, so you don't have a customer rep. Now, this bot can help you in those times, right? It can like answer generic questions. You don't have to select, okay, what do you have the query about? Do you have query about billing? Do you have query about your like technical assistant, things like those? Do you need technical assistant? You can directly ask the question and it will give you a response, which would be close to a human response. And then if it feels like it's getting overwhelmed, it doesn't have the answers, it can directly connect to a customer rep if there is one available. So those kind of things like personalized bots, those are gonna happen as well. The other thing that's gonna happen is basically lot more D2C,
D2C?
direct to consumer.
Direct to consumer, you mean? Okay, yes.
Yeah. Because now they have those tools as well, and those could become more prevalent, and like people can as this whole thing is getting democratized. In my opinion, people will become more AI savvy, data savvy, A/B test savvy, and landing page optimization savvy, and then like do better in their business. Yeah.
And these are ways Causal Funnel is helping SMEs and new businesses increase traffic and increase conversions as well, right?
Yeah, exactly. So, for example, you send like marketing emails, right? Now, one big advantage now that you have is you can generate images artificially, right? You don't have to, like earlier creating an image that you would have to hire a graphic designer, take a picture, they would do the touch up and make it really swanky and all that. Now you can do that just by a click of the button, right? You can generate like really personalized images. What I mean by that is like the text that used to be personalized. Okay, yeah, you browsed all these items And then like, okay, buy this one. Now it would be the image as well that would be personalized. So that's a big advantage, right? Visual cues are very important for humans, and that would lead to better conversion as well. Of course, it would saturate and all that, but at least the first movers would have that advantage. So there's that. Now creating videos automatically, that's also gonna happen. The videos creation is still a bit choppy, but yeah, we are getting there. Yeah.
Have you seen the latest iteration of Sora from I think is it from OpenAI or it's from...
I think so. Yeah, I think it's OpenAI. So
it was quite impressive.
It's impressive. Yeah. I also like the name. I think it was based on wind in Japanese or something, right? Yeah,
maybe. Okay.
Yeah. That's
All
my
right.
understanding. I could be wrong. Yeah.
Okay. All
Yeah.
right.
Yeah.
I mean, great transformation of digital marketing and the e-commerce sector in general. Do you think AI, when applied to digital marketing, will also cause some drawback and some backlash? Maybe, consumers have also privacy concerns. Consumers are now going to be increasingly bombarded by all those ad messages that are hyper-personalized to them. Do you think there will be some form of ad fatigue or general backlash against all these practices that are becoming maybe too intrusive sometimes?
Yeah, I think it's gonna happen. So ad fatigue is slightly I would say kind of tangential to the whole that privacy concern, right? Yeah, of course, due to privacy, you will have ad fatigue, but the privacy concern is a big problem is because there is something called third-party cookies, right? So, for example, you have like a like button of a big company, right? Now you have that like button on, say, ABC News, and then when you go to Target, you have that like button as well, right? So whatever you browse there on Target, when you go to ABC News, they know because it's the like button at both the places, right? Now, so your browsing behavior there can be used to give you targeted ads here on the ABC News, right? So that's when the privacy becomes much more kind of prominent, right? And so what's happening now is Apple came up with this whole privacy, I forget the name, but in just like a year or 2 years back, where they kind of like they were not storing third-party cookies on the devices, right? So if you go to Target and then you come to ABC News, the cookies would not be there, right? And then even the first-party cookies, which are basically the way to track people when they go to the same website, say they visited target.com today, and then 7 days later, even if they did not log in, Target would know because it drops a cookie on their device. So those cookies are getting wiped out in 7 days. So that there are some techniques already which are kind of, alleviating those concerns. But the bigger question still remains, which is a valid question. It's an equilibrium, I feel like, which would be achieved based on how much pushback is from the consumer, because who it hurts most is the small and medium-sized businesses. We have a ton of example of SMBs who are like, I don't know where my ads are going. The tracking is totally failed. I used to do really well earlier. Now my ROAS is like tanking. I don't know where my users are seeing my ads and like what channel should I advertise on, right? Bigger companies, they already have like their own pixels, right? Google has Google Analytics, Facebook has Facebook Pixel, Amazon, everybody buys on Amazon. So what it's gonna hurt more is the small guy, right? And that's where we also have this kind of this whole idea of like providing this data science and AI in a toolbox for SMBs where they can still survive in this environment.
So Abhi, tell me a bit more about Causal Funnel again. So you provide that AI toolbox for companies and clients, and do you provide Is it like an off-the-shelf product, or it's a personalized, customized solution that you provide?
So some of it is off the shelf, right? So like simple, like slightly like okay, a little bit of AI, but not a really strong AI persona nudges, right? Okay, you analyze your data, you saw that your first-time visitors are buying at half the rate of your returning customer, so you find a technique to identify your first-time visitors, and whenever they are there on the store, just nudge them with an incentive, right? So these kind of simple things you can just take off the shelf, right? Now more complex things like landing page optimization using A/B test and like a store personalized AI bot. So you give your frequently asked questions to us, we will train an AI bot for you. Those are like more customized, so we have to train the data much more rigorously and give that to you.
And what about fairness in those AI algorithms? Sometimes people say that when they train them, they use data that might be skewed. And are these like real case scenarios? Are these happening frequently, or is this something that is rare in
No, it happens. So let me give you examples. Some company made a phone, right? And they have the facial recognition, right? And they trained their algorithm on certain data sets. And when another kind of person wants to open that phone using like their face, it makes it difficult, right? So it's not just like a fairness concern, it's actually a business concern. You're not able to solve those consumers properly because your algorithm is only trained on like a very on a
certain
subset,
type of people in some location.
Subset of your data, right? So I think that concern is there, and like I said, we have only one planet, right? If your neighbor is in trouble, you are in trouble as well, or if your neighboring country is in trouble, you are in trouble as well.
Are companies working on solving these problems?
I think so. I think everybody is concerned about it. Okay, there might be biases, right? And like I assume that everybody has a good kind of a good place in their heart, and everybody good intentions. Everybody is kind, and like they're trying to solve the problem rather than create it. So I think people are solving that problem, but I think definitely there is more to be done, a lot more to be done. Because you cannot be isolated. Like I said, we are all we're all like joined together. So yeah,
absolutely. What about concerns that AI might take away some people's jobs? How do we address this concern? Yeah.
It's a great question again. Like it's been a perennial question whenever there is a new kind of tool that we come up with, right? So I mean, of course, we have that famous example of Luddites, and Luddites, right? The whole Luddite thing when the factory they started breaking machines and factories. So when the machines came in to do the work for humans, and like when in England there would be these Luddites who would like go in and like do these sneaky raids and break the machines. But eventually industrial revolution happened. Machines started doing majority of the physical labor that humans were doing, and like we created new kinds of jobs, right? So I am of that opinion that new kinds of jobs would be created, right? I'm very confident about it. The reason is that that's been like, if you think even logically about, I mean, I won't like, again, I could be biased, right? But I think we should keep that in mind as well.
Yeah, but for example, coding these days, you can code using those generative AI tools like ChatGPT or others. Is the coding is the job of is like the career of a coder now under threat, or coders should basically learn to upskill and then maybe use those tools to code faster?
Yeah, so here's the thing: as long as the fruits of the machine labor is distributed equally in the society, I won't say like again, like the whole equal thing is, so it is distributed fairly in the society. like then if everybody is starting at the same standard, right, then you would always have like people have different skills. For example, singing might be a great thing, or creative thinking, right? And those would be charged more, right? There would be basically product for those, or like you can sell that, right? So what I mean by that is you have to have a certain set of standards that you can set, right? Okay, robots are going to do the jobs, right? Then you get like some kind of a basic standard of living for everybody, right? Like it's not like the robots are only doing the jobs for the rich people and all the poor people are like stranded. Then there would be new kinds of work, right? The poor people would also be free with their daily chores, like their basic needs, like food, water, shelter, that's taken care of by the robots. Then there would be new kinds of jobs. You see what I'm saying? And then
they'll do more strategic things, maybe.
Exactly. There would be right. So I feel like we can solve these problems if we think from a good nature and from a perspective that hey, we all have to live together and make sure that we don't create a problem for others, right? Yeah. So I think it can be done. I feel that.
All right. What do you think about the field of prompt engineering? Is this an exciting field today to be in and to have a career in it?
So, I haven't looked much into it. I'm not very, very sure about it. If I was a fresh graduate out of like college, I would basically go see how I can utilize your open source algorithms to build products that I can sell, right? That's what I would do. Because I know there would be new kinds of jobs like we discussed, and like we'll have to wait and see how things pan out. Yeah.
I see. Okay. On that, what resources can you recommend for listeners who want to learn more about AI and machine learning on their own? What we discussed today is very exciting, but I'm sure there's a lot to learn. Do you have any specific sites or resources that you would recommend to people who are interested?
Yeah, absolutely. I would recommend so if you have a non-technical background, start from like YouTube lectures for Andrew Yang or like Jan LeCun or like all these greats, right? And there are a lot of tutorials as well. You will get a basic idea. Try to read some papers as well, like on Archive or like Google Scholar. Do that. If you are more technical, I would say start from linear algebra, right, and do like probability. Right,
Bayesian probability, right?
Well, we can argue about it. It's a fascinating debate between Bayesians and frequentists. So we can spend our whole lifetime just arguing about it. And start linear algebra is you gotta go do that. Probability. If you're more enthusiastic, learn a little bit of measure theory as well. And then, just basic algorithms, start from like, simple naive Bayes to all the way to deep learning and, simple classifiers to all the way to like, encoders and decoders and sequence to sequence, classifiers. Yeah.
I see. And for business people who don't want to go into the technicalities of AI or build an AI, do you believe there is in the future a field where there will be like AI for business, like kind of AI education for business people to sell AI, to talk about AI, to consult about AI? Do you think that's a field that's going to grow?
Absolutely. I feel like, as we talk more and the intricacies of these tools become much more common and people are more comfortable talking and using them, there would definitely be those, right? So, like Ford, right? He did the whole assembly line for cars, and that basically, shot up the whole thing, right? So I think that's gonna happen. It's a pattern that's gonna repeat again and again. Whenever we come up with new tools, there would be, new folks who would look at it in a very different way and capitalize that to bring in new ideas and products. Definitely, I have no doubt about it.
Okay. Question to you: Gemini or ChatGPT?
Oh my God! Causal funnel.
Good answer. Good answer.
Because
Good answer.
hey, we are not big, but hey, we'll solve your problem for your small store.
Okay.
Awesome.
Okay. Cool. Abhimanu, for those who want to start a career in the field of AI or machine learning, do you have any tips that you could give or any advice, especially for the young listeners who are now maybe in college or university?
Yeah. So I would say, if you want to do like research in AI, I would say like, having a strong set of skills and like basic, maths, etc. is good, like algebra, probability, and measure theory. And then if you want to do like more business oriented, start working off of open source projects, right? There are a ton of those open source models. If you want to just create tools, I would say start contributing to open source tools. Join a startup that is working on that. I would recommend that. Yeah.
I see. Well, that was a very exciting talk with you today. Any final words, Abhi?
I think the future is bright. I feel like people are doom and gloom, and which we should have those people as well. But we should also not lose lose our bigger perspective in in this setup. So I think that's my final word. Yeah.
Okay, that's great. Thank you very much for being with us today.
Yeah.
And it was a very exciting discussion about AI and machine learning. And I think we should talk again maybe in the future.
Absolutely.
Because that's a field that is going to
Growing,
change and
yes.
evolve over time.
It's gotta grow. Yes.
It's gonna grow, and I'm sure there will be like new things and new discoveries by the time we talk again. So thank you very much, Abhi.
Absolutely, and thank you, Imad. I'm really impressed by your credentials, and I'm really bad at music. I bought 3 guitars. could never learn to even play one song or even one of those. So I'm really impressed if I meet someone who can play and sing and do those things really well. So that's impressive.
Well, thank you, sir. Okay.
Thank you.
Take care. Speak soon.
All right. Take care, everyone. Bye.
Bye.